Students, we will start today B.sc 4th sem of my syllabus in organic chemistry part, unit 3rd aromatic amines, that belongs to 4 hours itself. In that, first we will going to deal about syllabus of aromatic amines. Okay. In the syllabus, in the first we will going to deal about the introduction part, that is the basic things, definition of aromatic amines, or simply amines means what. Okay. Next we will going to deal about classification of amines. Okay. Classification of amines. Next, distinction between primary, secondary and tertiary amines by nitrous acid test. Next part we will going to deal distinction between primary, secondary and tertiary amine by nitrous acid test. By nitrous acid test. Okay, that we will going to deal third part. Next, after that we will going to deal basic character of methylamine. Basic character of methylamine. Next, basic character of aniline. And as well as basic character of carbohexylamine. Basic character of carbohexylamine, that we will going to deal. Next, amine salts as phase transfer catalyst, that we call it as a PTC. Amine salt as phase transfer catalyst, that is PTC, we will going to deal. Then after that we will going to deal mechanism of Hofmann rearrangement, or we can also say it is as a, we can going to deal about Hofmann rearrangement along with their mechanism. And after that we will going to deal about Gabriel thalamide reaction we will going to deal. Next we will going to deal about diazotization. Okay. Next we will going to deal synthetic applications of diazonium salts. Okay. And are salts, or we can also say it is as in reduction we will going to deal, salt reduction. Next we will going to deal about Sandmius reaction, and lastly about coupling reaction. These all part we will going to deal in the topic of aromatic amines, which belongs to what? 4 hours. So in this case, which is the very important part, they may ask in your exam point of view. I will tell once again this all at the last class also, and as well as we will discuss it once again, okay, while studying this complete topic. Then also I will tell you about classification, they may ask for 5 mark, about definitions they may ask, On PTC they may ask the question, then rearrangement they will ask questions, again diazotization also they can ask the question, Sandmeyer coupling also they can be asked questions. So some important part also available or also present in this case in aromatic amines topic. Okay, so let's start today the introduction part of topic aromatic amines. So in the introduction, so what is the meaning of amines? Amines are, let's see, amines are alkyl, amines are alkyl, aryl, alkyl group, aryl aromatic group, or alkyl aromatic plus aliphatic groups. Amines are the alkyl, aryl or alkyl derivative of ammonia. So what are amines? Amines are the alkyl, aryl or alkyl derivative of ammonia where 1, 2 or 3 hydrogen atoms replaced by what? Hydrogen atoms replaced by alkyl, aryl or alkyl derivative groups. Replaced by alkyl, aryl or alkyl derivative groups. So what I mean to tell you is that amines are the alkyl, aryl or alkyl derivative of ammonia where 1, 2 or 3 hydrogen atoms replaced by alkyl or alkyl derivative groups. Okay, then let's give one example for that. Consider this is the function group for amines. Okay, and in this case NH2 which will be there, this particular NH2 may be get attached to what? R group, RNH2, isn't it? Again here NH2 which will be there, here hydrogen atom may again get replaced by another R group, isn't it? Or this again get replaced by another one more R group, isn't it? So this is in case of what? Alkyl groups. I have told about this alkyl groups. Now what about the aryl groups? We can discuss here about aryl now. We will see aryl groups. So in case of aryl groups, which is the aryl part, or tell me one example for aryl. Yes, C6H5, or we can say it is as an what? Phenylic, benzylic group, isn't it? So benzene ring we can consider here. This is one of the common example, NH2, isn't it? First, second one example, another one hydrogen atom replaced by another one benzene ring, here NH, isn't it? So this is another one example, isn't it? Now third example, 3 hydrogen atom replaced by 3 benzene groups, isn't it? We can give this is an example over here. This is aryl. Now third part, which is the third part? Alkyl groups. So what is alkyl? Alkyl means one should be present of, yes, one should be alkyl group and another should be aryl group. So one example for that, and it may be of aromatic amine. Okay, so here example I will give for alkyl. See, this is what aryl group ours, and here one alkyl group CH2 I will write, and here what? NH2 I will write. And again another one example, here one benzene ring again I will engage, and again I will here two groups I have to engage over here. So again I will put over here what, NH, and again here CH3. And another one example I will take over here. See, 3 benzene rings I will going to take over here, and I will put over here CH2, here N, here CH2, again one benzene ring attached to that particular CH2 group, again here CH2, and one benzene ring should be attached over here, isn't it? So these are some examples. So what I want to tell you is that amines are the alkyl, aryl or uralkyl derivative of ammonia. This is general group for ammonia, isn't it? NH2. Large number of amines have also been synthesized in the laboratory, which are used as a polymer, dyes, drugs, isn't it? So again this RNH2, RNHR dash, this R group should be what? Alkyl group. Maybe it is of CH3 group or any chain, alkyl chain. Next, aryl group. Here this particular benzene ring can be act as an aromatic ring. So aryl. Again uralkyl. One should be which one? Yes, alkyl group. Another should be which one? Aryl group. Isn't it? So this is are the about amines. Amines are the alkyl, aryl or uralkyl derivative of ammonia, where 1, 2 or 3 hydrogen atom replaced by alkyl group, aryl group or uralkyl derivative groups. Okay, this is about introduction. Amines are widely distributed in the nature. Amines are widely distributed in the nature. So in the which form they have distributed in the nature? They have distributed in the nature in the form of what? Proteins. In the form of what? Vitamins. Okay. In the form of what? Hormones and alkaloids. Amines are widely distributed in the nature in the form of protein, vitamins, hormones and alkaloids. And also large number of amines also can be synthesized in the laboratory, isn't it? Large number of amines also synthesized in the laboratory. And where they can be used? They can be used in which industries? They can be used in the polymer industry, or they can be used in the dyes industry, or they can be used in the what? Drugs industry. Okay, these are some common application of amines. Next part we will going to deal about classification of amines. So classification of amines based on the number of hydrogen atoms of NH2 ammonia replaced by alkyl group, aryl group or uralkyl groups. Amines get classified mainly into 3 types, which are those. In that first type which will be there, primary, next secondary, and third one tertiary. Okay, so what I mean to tell you is that alkyl group, if it is replaced by this particular NH2 group, one NH2 group, no, then it is alkylamines. Aryl, arylamines. Uralkyl, uralkylamines. Okay, so one by one we will going to deal. In that first we will going to deal about the alkylamines. So just see amines, functional group, general formula. First we will going to deal about primary amines. Primary amines, so which is the functional group NH2 and general formula RNH2. So here RNH2, R may be any alkyl group. Next, secondary amines, general group, functional group NH. Next general formula R NH R dash. Okay, next third one, tertiary amines. Tertiary amines, here N R N, one is for R dash, another is R double dash. This is about what? Alkyl groups, replaced by alkyl groups. Next, again this particular classification we can consider this is as an A. Now B. These amines are further divided into two categories, which are those aliphatic amines and aromatic amines. Amines further divided into two categories. First, aliphatic amines, and second, aromatic amines. So we will see this one by one. The word itself indicates that aliphatic amines, amines in which nitrogen atom is directly linked to the 1, 2, 3 same or different alkyl group is called as what? Aliphatic amines. What I mean to tell you is that nitrogen atom is directly linked to the 1, 2, 3 same or different alkyl group is called as what? Aliphatic amines. So what is aliphatic amines? Amines in which nitrogen atom? This particular NH2, in that this N is there, this nitrogen atom is directly linked to 1, 2, 3 same or different alkyl groups. Okay, they may be of primary amines, secondary amines or tertiary amines. So amines in which nitrogen atom is directly linked to the first 1, 2, 3, first, second or third same or different alkyl group are called aliphatic amines. They may be primary aliphatic amines, they may be secondary aliphatic amines, or they may be what? Tertiary aliphatic amines. Isn't it? They may be primary, they may be secondary, or they may be tertiary. In the form of table we will see. So see, just primary aliphatic amines. Here in case of primary aliphatic amines, only one carbon is attached to directly to the what? Nitrogen group. Okay, NH2, here I'll write CH3. This is for same carbon. Again for different alkyl group, same alkyl group it is, isn't it? So for different alkyl group only one. Here CH2, CH3, NH2. I hope you are getting the term. What I want to tell you is that doesn't mean that how much long chain it is, but here attachment of only one nitrogen atom. Here how much big chain, it doesn't matter. Here maybe of, again you can take here example just like of CH2, CH2, CH3, 3 carbon, 4 carbon, 5 carbon. The thing is that only one carbon which should be attached to this particular nitrogen. Okay, that of same or different alkyl groups, that we call it as an what? Primary. Now next part, what about the secondary? In case of secondary, here two CH3 groups should be or 2 carbon atoms should be attached to this particular what? NH2 group, isn't it? So here this, is it possible to write here too? No. Valency of nitrogen get changed over there, isn't it? So here again CH3 only one nitrogen. So again different alkyl group, we can take an example here, C2H5. Instead of taking here CH3CH2, I have to go over there C2H5, and again here NH, and again here CH3, isn't it? So what I mean, this particular nitrogen atom is just get attached to this 1 and 2, isn't it? Two different. Here same kind of, only one, isn't it? Nitrogen atom, same alkyl group, different alkyl groups, isn't it? So now next part, what about the tertiary? CH3, N, CH3, here CH3. Again here I can take directly example in this way. Here we can take like this, isn't it? So here CH2, CH2, CH3, here CH2, CH3, CH2, CH2, CH3. Different alkyl groups attached to the only one nitrogen atom, isn't it? This is about tertiary. Now the next part, aromatic amines. So next term, aromatic amines, and these aromatic amines are of two types. Which are those? First one is there, that is aryl amine, and second one is there, that is alkyl amine. First one aryl amine, and second one is there alkyl amine. So let's see one by one. First aryl amine. So what is this particular aryl amine? Amine in which nitrogen atom is directly linked to the primary, secondary, tertiary aromatic ring. They may be of primary, secondary and tertiary, isn't it? Means what? In the aromatic ring, consider if it is benzene is an aromatic ring. This is the first position, this is second position, this is third position. In this three, any of position attached by the nitrogen group, isn't it? That we call it as an aryl amines. Amine in which nitrogen atom directly linked to the first, second, third aromatic ring. They may be of primary amine, secondary amine or tertiary amine. Amines in which nitrogen atom is directly linked to the aromatic ring. So just see now, primary aryl amines and secondary and tertiary. So first we will going to deal, again these aryl amine get classified mainly into three types. Which are that three types? We are already familiar with that. That is primary aryl amines, primary aryl amine, secondary aryl amine, and third type is what? Tertiary aryl amine. So one by one we will going to deal. So as we already know the definition of primary aryl amine, only one hydrogen atom in this particular ammonia are replaced by the aryl ring, that we call it as in what? Primary aryl amine. Let's take an example for that. Here NH2 I have to write over here, and to this NH2 group one benzene ring should be attached over here, and name for that is aniline, isn't it? Or we can also call it as an what? Amino benzene. Again one example. Here benzene ring. Next here NH2. Here CH3. Orthotolidine. This ortho position CH3 group is there, so it is toluene. To benzene ring CH3 we can call it as an toluene, and this amino group is present at the ortho position of this CH3, so it is orthotolidine or we can also call it as an orthoaminotoluene. Isn't it? Now third example, this particular benzene ring, NH2, NH2. So para diamino benzene. To this para, this is ortho, this is meta, this is para. So para position, again another one amino group is there. So para diamino benzene. Isn't it? This is the name. These are some examples for what? Primary aryl amine. Now let's take one example for secondary aryl amines. We can also call this as secondary aromatic amines. Second one, secondary aryl amines. Okay, let's take example for that. Secondary means to this NH2 group, 2 hydrogen atom replaced by the aromatic ring, isn't it? So we can write, or we can take here example. Consider this is one benzene group, only one H should be present over here, and this is another aromatic ring is present over here, and name here 2 diphenyl or 2 phenyl groups are there. We can also call it as an diphenyl amine. This is example for secondary aromatic amine or secondary aryl amine. Now let's take an example for tertiary aryl amine. So tertiary aryl amine, yes, 3 hydrogen atoms get replaced by the aromatic ring. We call it as an what? Tertiary aromatic amine. Okay. So this is tertiary aromatic amine. So a name for that, triphenyl amine. Isn't it? So these are some examples for aryl derivative. Now the next term, alkyl amine. So next term is which one? Alkyl amine. So what is this alkyl amine? Amine in which nitrogen atom is attached to the side chain of same or different aromatic ring. So what is alkyl amine? Amines in which nitrogen atom is attached to the side chain of same or different aromatic ring. Alkyl, it means aromatic ring should be also present, and alkyl group also present over there, isn't it? Now first, primary alkyl amines or primary aromatic amines. So what I have told, aromatic means there must and should be presence of benzene ring, aryl group, isn't it? And again alkyl group means there is a presence of one alkyl group, isn't it? And next one should be hydrogen atom substituted by that alkyl group. So this is the example for primary alkyl amine. So what is the name for this particular group? Yes, is there any guess for this? I will not tell in this video. You have to guess it. Okay. Now the next secondary one. Secondary aryl alkyl amine. Secondary aryl alkyl amine. So in the secondary what will happen? 2 hydrogen atom get substituted, isn't it? So here consider this is one of the aromatic ring, that is our benzene ring, and again here the NH group is present, another group should be CH3, that is alkyl group. So what the name? N methyl aniline, isn't it? This is about secondary. Now next, third one is of tertiary. Tertiary aryl, alkyl or uralkyl amine. So again, in case of tertiary, 3 aromatic rings should be there, because 3 hydrogen atom along with that nitrogen get substituted by alkyl group as well as the aryl group, isn't it? Again here CH2 and one benzene ring, isn't it? So this is about third. I will not tell name of this also and first also. You have to guess it and you have to reply me in the comment box, or you can don't reply in the comment box. You can reply thorough in the notes itself. Again, after this we are having, based on the substitution group, that is simple amine, mixed amine and quaternary ammonium compound. Only these types are there, and after that we are going to dealing about nomenclature, and after that we are going to deal about the preparation. So let me revise the today's part. First we saw about the introduction, what is the meaning of amines. Amines are the alkyl, uralkyl or aryl derivative of ammonia, where 1, 2, 3 hydrogen atoms are replaced by what? Alkyl group, aryl group or uralkyl derivative. So in this particular NH3, ammonia should be NH3. Here 3 hydrogen atom, in that one hydrogen atom replaced primary, 2 replaced secondary, 3 replaced tertiary. Again aryl, 1 replaced by aromatic ring, 2 replaced, 3 replaced by aromatic ring. Aryl, uralkyl, here 2 should be 1 replaced along with 1 alkyl group, aryl group, alkyl group, aryl group, 3 replaced alkyl group, aryl group, isn't it? Are alkyl derivatives. Amines widely distributed in the nature in the form of protein, vitamins, hormones, alkaloids, and also we can prepare in the laboratory also, and we can use this for the polymers, dyes and drugs. After that, classification of amines, we already know that based on the number of hydrogen atoms of NH3 replaced by the alkyl allele or alkyl group, they can be classified into general types, primary, secondary as well as tertiary. Again here amines functional group and general formula: primary NH2, RNH2, RNH R dash, RN R dash, R double dash. Primary, secondary, tertiary. Next, amines are further divided into 2 categories: aliphatic and aromatic. As I have already discussed about it, which NH2 group is directly linked to the same or different alkyl group, we call it as an aliphatic. Next, here same different, based on that again we are having types. After that, aromatic amines which are there, they can be classified into aryl amines or alkyl amines. The aryl amines, amines in which nitrogen atom is directly linked to the aromatic rings, may be of primary, secondary, tertiary. So again primary only 1, secondary 2, tertiary 3, isn't it? Then uralkyl, amine in which nitrogen atom is attached to the side chain of same or different aromatic ring. Again here primary uralkyl, secondary uralkyl, tertiary uralkyl amines. Again next type is there, based on the type of substitution group. Actually secondary and tertiary aromatic amines or simply aliphatic amines get classified mainly into these types. In that first type is there, that is nothing but simple amine. Okay, so what is this simple amine? Identical groups attached to the nitrogen atom. So what is simple? Identical means same. Identical groups attached to the nitrogen atoms. Attached to the nitrogen atom. Okay, so we can take here example: CH3 NH CH3. What it is? Dimethylamine. And again NH, which is this? Yes, diethyl. Here NH, we can tell dipropyl. Next one, mixed amines, different group attached to the nitrogen atom. Here we took example, not same. Here both sides are different itself. And third type which will be there, quaternary ammonium compound. Quaternary ammonium compound. So in this case, derivative of ammonium salt in which all 4 hydrogen atom of ammonium ion replaced by same or different alkyl or aryl group, isn't it? Alkyl or aryl group, that we call it as an quaternary ammonium compound. All 4 hydrogen atoms of salt. This is salt. Okay. Maybe containing charges on it. Isn't it? Positive or negative charges. So that we call it as a quaternary ammonium compound. Now in the next class we will going to deal about the nomenclature of aromatic amines. We will stop here only. Thank you.